All right. So now we're actually going to look at coming up with the probability. The things that you need to remember with probability. Probability is a ratio, which means it is a fraction. You can write probability as a fraction, as a decimal, or as a percentage. Okay, it's all the same. So the ratio is the size of the event over the size of the sample space. So in the bottom of your fraction is the total. How many total things can I do? Okay, so if I'm flipping a coin 4 times, my total is 16. Okay, you remember when we did the 2 times 2 times 2 times 2? Because each time you had 2 options for each throw, that's what's going in the bottom. Okay, in the top is the event that's happening. Okay, so we're going to start off nice and slow. Okay, example 1 says, I have 12 boys and 15 girls in a class. What is the probability that a boy is called out of class? So in the bottom, I need my total students. Okay, Kimberly said that's 27. Okay, in the top, what do I want to find? I want to find a boy. So in the top is how many boys? Well, Kimberly says I have 12. The last thing I need to do then is, can I reduce?
They both can be divided by 3.
Both can be divided by 3, which leaves me with what? 4 over 9. You're done. I told you it wasn't going to be that bad.
Wait till it is.
I just said wait for it. Just wait for it. It's coming. I know it's coming, Miss Smith. It's coming. Okay. Example 2. A die is being tossed once. So in the bottom, I want sides of a die. How many sides are on a die? 6. So I have a total of 6 that it can land on. I want the probability of rolling a 1. So in the top, I want a 1. How many 1s do I have?
1.
Bam. Okay. When I scooch on over to puck B, I'm still talking a die. So guess what? My total's still 6. But now in the top, I want an even number. What numbers are even on a die? 2, 4, and 6. So that means I have 3, which reduces to 1/2. Questions? Okay. A candy jar is filled up with Skittles. We've got 6 green, 8 red, 4 yellow, 7 purple, and 5 yellow. We got more yellow? Well, dang. They really threw one for a loop here. Okay, so before I can do anything, I need to know how many Skittles are in my jar. So I need to get a grand total on my Skittles.
30.
30?
Yeah.
So that means both of these will be at a 30. You need to get that total number first. Okay, of those 30, how many are green?
6.
Reduce. 1/5. Of those 30, how many are not red? Okay, it says not red. And you said 24. 22. You've got 8 red, which means I have 22 that are not. So 11 over 15. So be careful, they can throw in that word not. You and me both sometime. Yes, you are. You really are. Right. Okay. So a 4-character password is made from numbers and letters, which are not case sensitive. What does it mean to be not case sensitive? How many letters do I have? We have 26. Okay, when it's not case sensitive, we have 26 letters. So I need to come up with my bottom number first. So if my password is 4 characters, okay, it's 4 characters that can be numbers and letters that are not case sensitive, what can I put in each one? 36. I have 36 options in each one. Well, I can also write this as 36 to the 4th. Or you can get the number, it's like 1 million something. Okay, so in the bottom, that's your total. 36 to the 4th. Those are all of your options. You've always got to think about that first. Okay? Now, in the top, I want my password to be all numbers. So how many options do I have to fill in each slot? 10. 10, 10, 10, 10. That goes in the top. Instead of writing 10, 10, 10, 10, I could write 10 to the 4th. It's the same thing. So your answer here is 10 to the 4th over 36 to the 4th, which is, where's my answer key? Oh, yes, I can hand you your calculator. I'm on the wrong page. Where's my page? This actually comes out to be 0.00595. Okay, if you would actually divide that. Okay, over here, I now want my password in the top to begin with 2 letters and end with 2 numbers. So I want letter, letter, which looks like what? 26, 26. Then I want number, number. 10, 10. So you could also write this as 26 to the 2nd times 10 to the 2nd. And then you would divide it by 36 to the 4th. This one comes out to be 0.04025. Y'all's notes are different than what I used to use. So now I'm flipping back and forth here.
You know what? I'm really tired that I'm so lazy.
You're tired of being lazy?
Yes. But there are times where it's like,
Okay. So we have some things called the complement of the event. Okay. When I'm asking for the complement, it's what they don't want. Okay. It's not the event. So think about it. Event 1, they want us to pick a black card. What is the opposite, or what else can I pick besides a black card?
red card.
Red card. A red card is your complement. It's what they're not looking for. Number 2, they want me to pick a heart. What is not a heart? A spade, a club, and diamond. Okay. Your third event says flip a coin twice and get 1 tail. Don't do it in terms of heads. We want to try to stick with tails.
So you get 2 tails.
So I can get 2 tails
Or no tails.
or no tails. Okay, so think about it. You're flipping it twice. So your total options are, I can get absolutely no tails, I can get 1 tail, or I can get 2 tails. I can't go any higher than that because I'm only flipping it twice. Well, they don't want us to get 1 tail. They want us to get the opposite of that, which makes it 2 tails or no tails. Okay, always, if they are talking in terms of tails, keep it in terms of tails. Don't start talking about heads. You will get yourself all kinds of confused. Okay. Make sure you're sticking with tails. Okay. Flip a coin 3 times. So before I even get to that, they want us flipping a coin 3 times and getting heads. So I can either get no heads, 1 head, 2 heads, 3 heads. Correct?
Yes.
Okay. I can't get 4 heads. I can't get 5 heads. I'm not flipping the coin that much. Okay. What is all heads? Which ones of these are all heads? The last one. So that means my complements are all of these options. None, 1, or 2. Does that make a little more sense to lay them all out and cross off what you don't want?
Either way works.
Either way works.
Mm-hmm.
Okay. Event. 4 questions, true or false test. We're talking true responses. So I can have 0 true, 1 true, 2 true, 3 true, 4 true. Okay. The event that we want, at most 2 true. What falls into that? At most 2 true.
2, 1, and 0.
2, 1, and 0. At most means 2 is the biggest I can have. So that means the complement then is 3 and 4. Again, your biggest thing is going to be deciphering what does at most or at least mean. Okay, 6. Doll. Oh, that's lovely. That should say roll. Roll a die 6 times and get at least 4 even digits. So we're talking even digits. So I can get 0 even, 1 even, 2 even, 3 even, 4 even, 5 even, or 6 even, because I'm rolling a total of 6 times. Okay. At least 4 even. What does at least 4 mean?
4 is the least you can get.
4 is the least I can get.
So
4, 5, and 6. So all of these are my complements. All of those are what they're not asking for. Joshua? Okay, try the last one. Flipping a coin 4 times and getting 2 tails. 4 times and getting 2 tails. So think about all of the options that you have available, cross off what they want, and then that's what they don't want. So 0 tails, 1 tail, 2 tails, 3 tails, 4 tails. What am I crossing off? 2 tails. It's just getting 2 tails. Doesn't say at most, it doesn't say at least. So everything else is your complement. So 0 and 1, 3 and 4. Jesus. We do really have a lot, don't we?
I told you.
Dang.
30 whole things.
Yeah, and they're jacking y'all tomorrow. Okay. So, the complement can make your life just a little bit easier.
Yeah.
The complement is always opposite of what I want. So, if my entire sample space is 1, and you know what we don't want, or you know what we want, you can subtract and find what we don't want or what we do want. So, for instance, example 1. We already found out that the probability of a boy is 12 out of 27. Well, if I subtract that from 1, that's going to give me 15 out of 27. Okay, so this was the probability of a boy, which means my answer when I subtract is the probability of a girl. So if you take the whole and you get rid of the boys, you're left with the girls. Okay, example 2. Eye color for students is recorded. We have blue-eyed students, brown-eyed students, green-eyed students, and 72 hazel students. What is the probability that a student does not have blue eyes? Okay, well, we can add it up. We can add up brown, green, hazel, and get my top number. Or I can take 1 minus my blue, and that will equal not blue. So my blue eyes are 150 out of 285, 93. You said 600? Okay. So if I have 150 blue eyes out of 600, that means we have 450 not blue eyes out of 600. And of course, you would need to reduce, which comes out to be 3/4 or 0.75. Okay, so the complement's supposed to actually make things a little bit easier. But you can always go back and add up 285, 93, and 72, and you get 450. Okay, either way works. It all depends on how your brain wraps around it. Okay, example 3. Let's try these all in complements. Okay, so again, I still need a grand total. How many students do I have? What's my grand total here?
30.
30? Okay, I've got 30 kids. So if I'm doing complement, I want an upperclassman, so what do I need to take out? Okay, I need to take out the freshmen and the sophomores, which is what? That's 14 out of 30. So if I take out the underclassmen, that means I've got 16 out of 30. Or 8 out of 15. Okay. Part B, what's the probability that a freshman is called out of the gym? I would not do the complement on that one. Freshman, I want a freshman.
Get to be 8 over 30.
8 out of 30 or 4 out of 15. What's the probability that an underclassman is called out of the gym?
It would be the first one backwards.
It would be the first one backwards. So 1 minus the upperclassman gives me the underclassman, or 7 out of 15. D wants a non-freshman. So 1 minus, if I want a non-freshman, let's get rid of the freshman. So we subtract 8 out of 30, which leaves me with 22 out of 30, or 11 out of 15. Okay, so the complement's not always going to help, but it can. It can make your life just a little bit easier.
Nobody tells me anything.
She's been coming to pick up this school.
You let me use my notes on that test, since I ain't got no partner.
I mean, we'll talk after class. Because at this point, I'm annoyed. You're sitting there with no notes on your desk. You sat there playing on your phone like you don't have a care in the world. And I'm done. I have no patience for it anymore. You've made your bed, lie in it. I'm sorry. It's not my fault you weren't here. I don't know what to tell you. Okay. If we want to talk complement with example number 4. Okay. So 1 minus. I want my answer to be at least 1/3. So what's opposite of at least 1/3?
And you get
100.
What does it mean to be opposite of at least 1/3?
you can get at most 1.
Okay.
So if at least 1/3 means that you can get a 2, a 1, or a 2, then you can get a 3, a 4.
So think about it. We're going from a number from 0 to 999. So at least 1/3. So that means 1/3 or
No 3s. I mean,
at least. Is 1/3? What does at least mean?
at least you can get a piece.
That's the smallest I can get. So I can get 1/3,
Or no 3s.
2 3s, 3 3s. What can I not get?
0 3.
0 3s. Okay? So I don't want a 3 at all. So if I don't want a 3 at all, how many options does that leave me?
Like
How many digits do I have?
3.
10. And if I'm taking out the 3s,
9.
9. So I can put any 9 of my remaining numbers in any spot that I want. So that's 9 to the 3rd.
Never mind. I got it.
Over in the bottom, 10 to the 3rd. Because that's my total amount of options.
Why do you put it to
Huh? Because you're talking about a 3-digit number. So my number has to be something, something, something. So I have 9 options, 9 options, 9 options, which is 9 to the third.
Okay.
Okay. So if you actually subtract that, you get 0.271.
Is there one like this one with this? I really hope not.
I do not remember.
And it's a take-home test. I'm so hurt.
And there's multiple versions of it.
What do you want to run another different test?
Yep.
Good.
Oh, that's fine.
I'm glad.
Although this class might be a little bit behind since I'm going to lose you all tomorrow. I don't know how long we're going to be down there. I don't know how long I'm going to have you in class.
You know what you should do?
This what?
You should record with your third and just tell us what.
Girl,
you do.
hell no, because they won't be quiet. They don't shut up. They take the first half before lunch. That's all the time they're doing their warm up, and then they start notes after lunch. Exactly. And probably don't finish the notes.
Well then, what a
So
class,
they take
right?
like 45 minutes to do a warm up.
Okay. So we've got 4 questions, and I want at least 1 A.
1A, 2A.
So that's 1 A, 2 A's, 3 A's, 4 A's. What does that not include?
0 A.
The B's.
0 A's. So my complement would be no A's. Okay? No A's at all. So Ashley said if I'm looking at no A's, that means I can get a B, a C, or a D. So I've got 3 choices to the 4th power because it's 4 questions.
Over.
Originally, though, I had 4 choices to the 4th power.
I did.
Did that just click?
Yeah.
I love when it does that. She's finally like, yes.
It's 0.683.
You can stop. 0.683. Oh my.
Damn, are we done yet?
This is the longest section.
This really is.
You just complain a lot.
She does complain a lot, but I mean, I
That's
totally.
beside the point. I'm right.
No, that is.
She says that's besides the point. All right. So when I set up these problems, I kind of set you up for success.
Failure?
So in part A, you are finding the total. So what you will use to divide through part B through part C. So consider a random experiment of tossing a fair coin 4 different times. What is the total number of possible coin flip combinations? Each time I flip a coin, I have how many options? 2. How many times am I flipping that coin? 4. So 2 to the 4th. There's 16 different ways I can do that. Okay, so that means when I get to part B, it's out of 16. When I get to part C, it's out of 16. Okay, even if part A is not there, you still have to do part A to do the rest of it. Okay, make sure you always have a total. Okay, exactly 1 head.
You can get 1 head, 2, 3.
We're bringing combinations back.
Okay. It'd be.
Okay, I want 1 head. This is why we're bringing combinations though, because think about it. I've got 4 spaces. 1, 2, 3, 4. I can put my head here, 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 or here. That's why we use combinations. Because combinations will take into effect that I can put it in any one of those 4 slots. So I've got 4 slots, and I want to fill
6, 1.
1. That's it. That's your answer.
Well.
4C1 divided by 16. And if you actually solve that, it's 1/4.
Wait, but I thought combinations can be over something backward.
It'd be 4 over.
This right here, when you plug it into the calculator, already does that for you.
How do we plug it in?
So, hold on. 4C1 is the same thing as doing 4 over
1 factorial.
1 factorial. So in the top, that would be 4 over 1 factorial. You don't want the bottom part of that to be factorialized. That's what this does altogether.
So how would you put that?
I'm going to show you. Give me a second. Okay. So in your calculator, let me minimize this for a second. Oh, I deleted my calculator. Give it a second. It's going to take a minute to pop up here. My computer. That's her chair.
I thought it was someone talking to me.
I did too. That's why I thought someone was listening to something.
What is this?
I didn't even know it was my chair.
All right. So to do this, you would do 4. You would go to math. You would scroll to probability. I want combination. So choice 3. 1. Hit enter. Divide that by 16. And if you want it as a fraction, you change it back to a fraction. Now, because this is going to be a take-home test, while I sent you the virtual calculator, if you leave it just as 4C1 over 16,
You will take
I will take it.
Okay.
Huh? On Canvas, you now have a virtual calculator that you can download onto a computer. And it is literally your calculator on your computer screen.
Well, that's
Why did you didn't tell us this?
I just found it last week when I was at Andrea's.
She told us.
I told you when I came back that next day.
you don't pay attention.
Girl, Bob.
She says,
You,
girl.
that's the first time I've ever not paid attention. You don't pay attention every day. She says all the time.
Okay.
Oh, when she said that last month.
All right. Part B said we were talking exactly 1 head. What does at least 1 head mean?
1, 2, 3, 4.
1, 2, 3, or 4? Okay.
No zeros.
No zeros. So I need in the top to do each one of these individually. So I want 1 head. So I've got 4 and I want 1. Or I want 2 heads. 4C2. Or I want 3 heads. 4C3. Or I want 4 heads. 4C4. So you would have to add up all those combinations together, then divide it by 16. All right. Again, number 2, I gave you part A, which will do the bottom parts for B, C, and D. Okay. How many different possible answer keys exist? I'm doing 6 questions, true or false. So each question has how many options? 2. You've got true or false. I'm answering that 6 times. So that's 2 to the 6th power. You can leave it as 2 to the 6th if that's what you want. 2 to the 6th, 2 to the 6th, 2 to the 6th. That's your bottom for each and every one of these. exactly 3 truths. So again, total amount of options, so 6. C, and how many do I want? 3. I'm done. Okay, think about part C. At most, 2 falses.
2, 1, or 0.
So at most 2 means I've got 2 falses, 1 false, or none. I need to write all of those as a combination. So I need to write, I have 6 and I want 2. Or I have 6 and I want 1. Or I have 6 and I want 0.
So when is it gonna be when the zeros involved? Like when it said there's
At most. If it's at most, it means the most we can get. is 2.
We're going to take care of your question in the next one.
If it says at most. Yeah, at most.
At most means you're at your highest number.
So that 2
At least means you're at your smallest number. Okay. Okay. So now we're at least 3 falses. So that means 3 is my smallest number. So I can have 3, 4, 5, or 6. Okay, you're doing it 6 times. So again, I have to write, I want 3, or I want 4, or I want 5, or I want 6. It's not too bad, right? You just say, as in like I'm torturing you and you just might die. Your mouth hurts. Come here.
No.
What, is it just the tooth? We can wrap a string around it and turn the door shut. Listen, see. Oh, good luck with that. They had to pull all mine out. They literally had to cut my gums open, crack my teeth in half, and yank them out.
I don't think that.
Why didn't you just tell me that? Because now I don't want to get them pulled out.
If yours are actually coming out, it won't be so bad. Mine were coming in at like an angle to the point where it was messing up all of my teeth. So they were going to put me under, but my sugar was too high and they couldn't. So I was awake for the whole thing.
Wow.
Yeah, it was cool.
Hey, that's not cool.
You didn't feel the pain. You just felt the pressure. It was pretty cool though.
No.
That is not cool.
If you get it, smile stars.
What she said.
All right. A 4-character password. A 4-character password is made from numbers and letters, which are case sensitive.
52.
We're now up to 52 letters. Okay. I need my bottom number first. So my
62.
bottom number is everything put together. So my password can be lowercase letters. It can be uppercase letters. It can be numbers. How many options do I have?
62.
62. I can put 62 different things into each part of my password. What am I raising that to?
4.
The 4, because it's a 4-character password. So that means 62 to the 4th is the bottom of each one of my answers. That's my total. Okay, so I started off with 62 possible things to put in each slot. Now they're taking away even digits. So what am I taking away if I'm taking away even digits?
2, 4, 6.
2, 4, 6, 8. That's not a digit.
0.
0. So I'm taking away 5 different things. So if I'm taking away 5 different things and I started with 62, how many things do I have left?
You have 50, wait, what was that? 7?
57. So each one of my spots in this one could have been filled with 57 different things. Again, it takes out 0, 2, 4, 6, and
I thought
8.
0 wasn't considered even.
Oh, right now. it's considered-
Think about it, if you put 0 at the end of a number, it makes your numbers even, that's why. 10 is even, 20 is even, 300 is even. So if you end a number with a 0, it's an even number, which
I
is why
think,
they're
yeah,
counting
it
it.
should be considered.
10 is even.
Right. Okay. So, see, they want me to start with a number and end with a number.
And
So, 4-character password, I want to start with a number and end with a number. So each one of those have now been reduced to 10.
then 52.
What about the middle? No,
26.
62.
Oh, we letter or a number.
Okay. In the middle, I now can have a letter or a number. So that keeps those at 62. (62) to the 4th. Okay. Now I want my password to use only lowercase letters. So that has restricted me down to how many options?
26.
26 options in each slot. So 26 to the 4th.
So how would you know when to multiply and to add? Like, when it's-
What do you mean multiply and add?
well, right there's the C. You're multiplying. For the other one.
When we did the 4
C
choose 1,
combinations.
the combinations.
Yeah, you're at. You don't
It's
know.
not that I don't know. I'm trying to figure out how to word it that it makes sense to you. It's not that, but have you ever had that teacher that is just so freaking smart that you're just sitting there and you're like,
Yeah.
Yeah, you. That's how I'm looking at you.
that's how you look at me?
That's how
Yeah.
That's how I've been looking at you the
That's
whole
how I
time.
look at Miss Hudgens when I
Yeah.
have her class.
Okay,
I
like,
look at her like,
I had a professor in college that he was brilliant. I could throw any math problem in front of him and he'd be like, it's blah, 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 blah. I'm like,
That's how you should look at Miss Miller.
Hmm.
I just look at you like.
so it's not that I try to dumb it down per se, but I try to put it in language that y'all will understand. Because if I talk in mathematical terms, you're just like, huh?
I'm just like.
do that.
Okay, so this password, okay? So this password, I've got to have a letter and another letter and another letter and another letter. So the word and means to multiply. Okay, when we were talking at least 2 ones, that meant 2
Or.
or 1 or 0, which then put in the plus.
I know, she's just really doing it.
But did that make sense?
Yeah.
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 Oh!
It's stupid.
Listen, I don't care. I will talk to you like goo goo gaga if it makes sense. I don't care.
To be fair, I look at all my.
She had talked to Riley.
Facts. Especially Miss Love. I'm
With love, I'm just like.
I was looking like, stop. Because just be quiet.
1. All right, let's get through these next 2 examples and we will stop.
I'll be like,
Thank God you.
No homework.
You said no homework?
If we can get through these, no homework.
They're
Oh, okay,
basically,
okay.
they're basically.
Okay,
That motivated me.
woo! Drawing 2 cards. Okay, we're picking 2 cards from a standard deck where replacement is allowed. What does that do to my amount of cards each time I pick?
It still.
It stays the same.
It stays the same. So, how many cards do I have to pick from?
52.
52. Each time I have 52, so my total amount is 52 squared because I'm picking 1, putting it back in, and then picking another. So that becomes my bottom. Okay, in the top now, I want to draw a king and then another king. How many options do I have?
You have 4.
4.
Yeah.
Because I'm putting the cards back in, I still have 4. So 16 out of 52 squared. Okay.
Are these the
Okay, in this one, I want face cards.
so the
12.
16?
What are my face cards?
Jack, Queen, King.
Jack, Queen, King. No aces. So I've got Jack, Queen, King of spades, clubs, hearts, diamonds, which, yes, Ashley, leaves me with 12 options. And because I'm replacing, I still have 12 more options. So 144 out of 52 squared. You put what? Oh my gosh. Meow. Miss Smith does what now?
Yeah, she does.
Miss Smith does
Every
what?
time we're doing a problem, you only put the answer for one that you know off the top of your head.
Yeah.
You don't never put the answer for none of the other ones.
I did too.
No, you didn't.
Wait a minute. Yes, I did. It's right there. Don't say that. Rude. Okay. We're still on replacement is allowed. So we're still on 52 squared. This time, I want a red card, then a black card.
You could do, no.
26 red,
And
26 black. I don't know that one off the top of my head. It's all right.
How
Got
much
an
would I
answer
guess?
key.
It is 440.
676.
Wow.
What the?
Out of bam. Okay. Take a look at the difference between D and E.
Okay, you wanna draw a red, then a, wait.
It says draw a red
It says
and.
And a
Okay.
black card.
There's a difference between then
And-
and. So when I'm talking then, that means I want red followed by a black. When they use the word and, I don't care which one comes first. I can do a red, then a black, or a black, then a red. So I have to do this twice.
I seriously thought you were repeating the
Okay, so red, then black, 26 and 26.
Is this the same answer?
Or
26.
means I'm going to add
26.
26 and 26 again.
So then it'd be 12.
So now instead of 676, we're now at
13,000. No, wait, 14,000.
Girl, no.
12.
Stop it.
1244? No, 1352. 1352, my bad.
See, I got it.
It says 13,000.
Yeah, 13,000. Oh, okay.
So basically what you just did was you doubled your chances because the order matters. Okay. You doubled your chances from then to create and.
I thought the order didn't.
Because it says and you can do it either or. Oh, it doesn't matter. You're right. You're right. My bad. I said that wrong. My bad. Yell at me. It's all right. I'll accept it. Okay. Here I want 2 diamonds in the top. There are 13 diamonds. So 13 and 13. 169. I actually know those things. I can go clear up to 225. Thank you very much. Because 14 times 14 turns into 196.
Oh, I knew that.
You just switch the 9 and the 6. 26?
Oh, you gotta think about that.
Oh, I hate you all. Why can't you all be quiet like the good girls in the back? I got good kids back there, and then I got my loud mouths right here. And then these poor people that have to be put into your category.
Especially with Samari out here.
We don't want you to be part of us anyway.
Okay,
We're all right.
So, take into consideration the difference between what we just did and what we're about to do. Draw 2 cards, holding on to the card after it's drawn. So now, the first time I'm picking a card, I've got 52. But now I have 51. So I can't do 52 squares because no matter what card I pick, it's going in my back pocket and I'm taking it away. We're cheating at some blackjack. Those cards. Okay, so now each bottom is 52 times 51.
That was a minus.
Right.
Okay, so now be careful because in the top, the fact that you're keeping the card also comes into consideration.
And 3.
And 3. Because I'm picking the same thing, I've now lost an option because I'm not putting it back. So 12. I don't know what the bottom is.
We do.
26.52. Okay. Here, 26.52. I want 2 cards with number values. All right. So my number values are 2, 3, 4, 5, 6, 7, 8, 9, 10. How many options? 9. 9 times. I'm sorry. 9 of each suit. So 9 times 4 is.
8, 7. I don't know. Oh, that's
9 times 4?
Mm-hmm.
That's 36.
9 times 4.
Oh, I was thinking 9 times 3.
36. So the first time I pick, I've got 36 I can pick
You
from.
got 35.
The second time I pick, I only have 35. 105 out of 221.
What?
It's reduced. That's all. It's reduced. That's the only answer I have on my paper. I didn't put the actual. Listen, I don't like you anymore. 26.52. Okay? I want a black card and a black card. So I start out with 26 and then 25.
I was gonna say, why not you go white?
Don't make this into a race thing.
Who brought race into this? I was just saying.
You.
No.
You just said, why not a white card?
Yeah. Or why not a blue card? You said.
Maybe yellow
Right. Come on now.
or orange.
What is the probability of drawing 2 cards that are the same suit?
Why can't they be different?
There are 2 different ways to attack this. Can you think of one of them?
The same thing.
What would I start with?
You gotta do them all different. You gotta do all the suits, don't you? I don't know.
There's 2 different ways to do this. So it all depends on how your head wraps around it.
You could do all the suits separately.
Okay, we could do all the suits separately. So if I do all the suits separately, that means how many cards do I start with to pick from? 13. Each suit has 13 cards, and when I pick that, I then only have 12. Well, to finish this off, because she only did one suit at a time, I would need to multiply that by 4.
Great brain.
Okay. It's not that it's brand new. It's just you have to take in all to consider.
So
Now, see, I would have done it this way. This is the same thing as 2652. So I would have taken it as I can pick any card that I want to start with. So I actually start with 52 options.
I was about to say that. We have done.
Once you pick a suit, then you only have 12. These are the same
See,
thing.
no, that would be.
It all depends on how your head wraps around it.
How like that doesn't have around me. So why wouldn't you go from 52 to 51?
Because you're picking.
Because you have to pick the same suit. So once you pick a card, let's say you start with 52, you pick a diamond. You need another diamond. So that only restricts you down to 12 options. Because there's only 12 diamonds left in the deck.
Yeah.
That's why it's the first one.
Okay. So you've got both ways to look at that.
So you